What we're going to do today is called the methanol demonstration. So what we have is, these are water jugs. People used to have water delivered to their homes in these. It's empty. Well, it's filled with air right now. And we have methanol. Methanol is a type of alcohol. It's not drinking alcohol. In fact, 10 milliliters of methanol, that's what we have here, is enough to damage your optic nerve and perhaps make you go blind. And 30 milliliters of this is enough methanol to kill somebody. So this is methanol, different than ethanol, but similar in the sense that it's highly flammable. So what we're going to do, we're going to pour the 10 milliliters of methanol into this jug. And you know that a flammable substance typically vaporizes, so we're going to vaporize it. So what we'll have in here is methanol vapor, and we're going to combust it. What's important when you do any combustion reaction is if you have a flammable source, is that before you actually execute your experiment, you remove the flammables. And I'm going to be wearing earplugs for this because this might be a little bit loud. Hopefully it's a little loud. One year I was able to blow out that ceiling tile up there. It blew the ceiling tile out and torqued it to the side, and all semester we had a ceiling tile that was out of place. All right, are we ready? Here's some methanol combustion. Now this is always a student favorite, so as long as we have all the materials, maybe we should try one more time. So let's get again the same amount. We'll get 10 milliliters of methanol, and we'll want to vaporize it. The fastest way to vaporize it, of course, would be to increase its surface area. So this should evaporate in just a moment or two. So I'm rolling it around to increase the surface area. Okay, let's combust the methanol. Oh boy, that's surprising. It really didn't do much at all. The first time we put 10 milliliters in and got quite the explosion. And the second time, it appears that nothing really happened, just a little bit of flame. So let's go to the equation, and maybe that can reveal what has happened here. If you look at the combustion reaction for methanol, what's required to combust methanol is also oxygen. So the first time we did this reaction, that jar was filled with air, which is about 21% oxygen. So when we had methanol in the jar the first time, we also had oxygen. This reaction went to completion, and we formed carbon dioxide and water. So these were the products that were made, and these products now filled the jar. Or another way of looking at it is that all of this oxygen was consumed the first time. So the second time, even though we had a sufficient amount of methanol, we did not have oxygen, so oxygen limited our reaction. So in this case, oxygen would be the limiting reactant. So this is a sort of a real-world example of when you might see limiting reactant at play.